My name's David Festa, and I'm Senior Vice President at Environmental Defense Fund. I'm in my 16th year at EDF, which I still find quite amazing. I've had several jobs, one of which was working with Jake when I was in the Oceans program. I also run our West Coast operations, and I am also in charge of the work that we do on building resilience, largely in agricultural and coastal communities, and I'll talk a little bit more about that. But just to give you a little idea of what's going to happen tonight, the three of us are going to talk for about 15 minutes, hopefully get your brains going, get some questions in mind or comments that you might want to have. Then we'll open it up for Q&A. The one thing that is really nice is when you introduce yourself, when you ask a question, so other folks can know who you are, and we can also know who you are. It's always a good thing. So I would ask that when you want to ask a question, just raise your hand and let us know who you are. And if you don't get a chance to ask a question, but you have one, just write it down. If we run out of time, just write it down. You have notebooks there. You can write it down, tear it out, give it to any one of us, and we will get an answer to you. So do I need to make any other announcements? It's all good? Okay, I got the thumbs up. So I'm going to launch right in. I mentioned to you that one of the things that I've been working on is building resilience, and you might ask, well, what is resilience? And resilience is the ability of a system, a human system, a natural system, to respond to multiple threats in a way that critical functions are maintained over time. And you say, well, is that adaptation? Adaptation can be a part of resilience, but it's a little bit different than resilience. I live in California, and you guys may know that we've had a lot of fires out in California. I live in a part of California where the way they deal with the threat of fire is to turn off my electricity and the electricity of 2 million of my other closest friends. That is an adaptation, but it is not resilient. Now, resilience would be looking at our building codes and land use zoning to figure out where are the places for people to live. It would be looking at farms and ranches and commercial timberlands and say, how do we help pay them to manage their lands in a way that reduces fire load? And it would be looking at the electricity grid and saying, how do we build microgrids and distributed power and have that connected through a central system in a way that allows us to respond very flexibly when we get 100-mile-an-hour winds and 1% humidity. Sometimes it really is important to depower these lines. So that's more of a resilient approach. Resilience to me is a source of great optimism. And the reason for that is that as climate change impacts are starting to be felt all around the world and in all these communities, it's really forcing people to think differently about their environment and what they need to do. One of the challenges we have with climate change is that essentially we're asking people to make sacrifices today or change their behavior today so that things 50 years from now won't be as bad. That's a tough sell. It's an important sell, and we're going to make it, but it's a very tough sell. Resilience is really different. Resilience says, whoa, wait a minute. Sea level rise is at my toes right now, and my house is right here. What am I going to do about this? Fire is coming down the pike. What am I going to do about this? So the upside of the changes that we're seeing because of climate change is actually motivating people to finally think differently about how they relate to the natural world and to do things differently. And I'll give you two quick examples before I turn it over to my two friends. Down in coastal Louisiana, this is one of the most conservative states in the union. It voted 58% for Trump, and its legislature is vastly more conservative than the U.S. Congress. But because they are facing the crisis of sea level rise, they lose about a football field of land every 90 minutes. It's a lot of land. They know that they have got to do something. And over the last several years, Steve Cochran, my colleague, has been down there building a coalition of folks to really think differently about what can we do to actually create a livable delta. And when we started this work, the government's plan was to build a giant dike out in the middle of the Gulf of Mexico. no one thought that would work. And we went to Baton Rouge, the capital, and said, do you guys really think this is going to work? And they said, well, no. But if we tell everybody we can't protect them, we're going to get voted out of office. And they were probably right. And so what we did was begin to work with the folks who realized that, you know, the status quo was not going to be here forever. They're going to have to do something differently. And we created what we called a design competition. And we brought together all of the local groups. There's a Native American tribe down there, the Homa Indian tribe, Cajun, Creole, industry guys, barge guys. I mean, this was a big coalition. And we provided them with designers and engineers and graphic artists, and started saying, you guys ask us the questions about what might be possible going forward. How might we save a part of the delta? And they came up with a plan. We do lose a lot of the delta, but we save about half of it, which is a lot compared to losing all of it, which is what the projections say. Put forward that plan. When the state saw that plan coming out of the design competition, they knew they had the political support to put together a realistic plan. That's the state master plan. And again, this very conservative legislature voted nearly unanimously for the plan that talks about climate change, talks about sea level rise, talks about the need to move people. You know, not everyone's going to be able to stay where they need to stay, or can stay where they want to stay. So they need to be able to begin to think about where to move. So I think this moment that we're in is both highly upsetting, highly stressful, but also is one of the best opportunities we've had in certainly my professional lifetime to really fundamentally rethink our relationship to nature and how we work with nature and put things in place that are going to make for a better quality of life for us and for future generations. So I'd like to turn it over first to Jake to talk a little bit about some of the work he's doing, and then over to Kristin to talk a little bit about the work that she's doing.
Is this working? Good. Thank you, David. So, as David said, my name is Jake Kreitzer. I'm trained as a marine scientist, and I've been with EDF almost as long as David. I'm also in my 16th year, and I was actually his first hire when David was running our oceans program. I got a few things right. Unlike David, I have more staying power. I've been with the oceans program that whole time. And that has taken me, you know, through sort of our oceans program has undergone, as I see it, 3 major phases. When David and I first joined the program, it was a much smaller program, scattered around the U.S., people in small teams working on very loosely connected projects. Few years later, we went through this major sea change where we grew the program substantially while also really focusing our efforts on fisheries management. And the idea there was, rather than chipping away at a bunch of little problems, we were going to find one and make transformative change. And so we had the right ideas, we had the right political opportunity, and we pounced. And that was a really exciting time. That actually occupied most of my career with EDF. But we're now in a new phase where our oceans program really has gone truly global in nature. During that time when we first started to focus on fisheries, it was almost exclusively on the U.S. Now, more of our work is actually outside the U.S. than in the U.S. And in fact, for the last 2 years, I've been leading the rapid growth actually, of our oceans work in China, which has been an adventure to say the least. And I'll talk a little bit about that at the end. But I actually want to step back to the work I did for the majority of my career, based here in Boston and working primarily on the historic groundfish fishery. So this is the fishery for cod, for flounders, for a variety of other kind of bottom-dwelling predators that live out in the Gulf of Maine. This fish had been the backbone of the maritime culture and economy of this region for centuries. There's a really famous book whose title is simply Cod, but the subtitle is a biography of the fish that changed the world. And if you read the book, it's not actually hyperbole. You know, there was fundamental economic and historical shifts that rode on the back of the cod fishery. Unfortunately, you know, over time, we came to heavily overfish that stock and many others. And in the middle of the 1990s, it just completely collapsed. Now, crisis often breeds opportunity, and that's where we stepped in and started to implement some major changes that have really started to turn that fishery around. And I'd say the 2 biggest ones were finally putting in place science-based, risk-averse catch limits that kind of got fishing mortality under control, and in parallel, creating a system of harvest cooperatives that fish those catch limits, which gave fishermen more security and flexibility to work through those trying times. And the science suggests a lot of what we did worked, that catch came down, fishing mortality came down, and what we expected was that the populations out in the water would then start to rebound. That hasn't happened yet, right? And it's been really, really frustrating. Because what was happening along the way was climate change was coming to the Gulf of Maine. And you know, it occurred to me recently that over, again, a 15, 20-year career as a fisheries biologist, for the last 3-4 years, I have spent much more time thinking about and trying to understand the effects of climate change on fish populations as I have trying to understand the effects of fishing on fish populations. So this is the problem we're dealing with now. And honestly, it's had psychological effects, I think, on many in the fishing industry here. They say, okay, we've suffered the pain of reducing catch limits. We've done all the right things. We think we're kind of managing fisheries well now, and now we've got this global problem that we can't do anything about. So if there's one message I want you to take away tonight is there are things we can do about it, right? And we're starting now to have this new conversation in fisheries management about what do we do to adapt to climate change and to build exactly the kind of resilience that David was talking about. And he made an important point, which is that a key aspect of this is looking forward into the future, right? When we talk about cod, I mean, I just did this. We talk about the history. We talk about its economic and cultural importance. We talk about the big wooden cod hanging in the State House up the hill and you know, what that means for our heritage. That's all very real and very important. But if we really want to understand where this fishery is going and how to get it there, we need to understand what's changing out there. And we've started to take some of these steps. So one of the issues I've worked on and off throughout my career is the role of marine protected areas, kind of aquatic national parks, if you will. This is arguably the most contentious issue in marine conservation. Many people feel this is the single most important thing we can do. Others feel that this is going to fundamentally wipe fisheries off the map. And it's been a decades-long stalemate. Now, actually, a few years ago, the Fishery Council that manages the fisheries here in New England created a new protected area in the northern Gulf of Maine where there haven't been any protected areas ever, and right now where there's no fish. And this, for this council, honestly, was a remarkable sign of foresight because they realized that warming waters were going to start to push the fish populations northward. They were going to be showing up in places where there were new habitats, there were new competitors and predators. You know, they were going to have to adapt to a new set of conditions, take hold, and hopefully become the basis of a rejuvenated fishery. To do that, we were going to have to lighten up fishing pressure. So that was an action we could take, and we did take, and that was encouraging. There's more we need to do. So we set catch limits in fisheries using rather complex mathematical models that try to estimate how many fish are out there and how hard we should be fishing them. Over time, those models have performed worse and worse and worse. Part of the problem for that is that climate change is having effects. And it's the model is assuming the system operates in a certain way, and it ain't working that way anymore. Part of the problem is also that the data we're putting into them are nowhere near as good as they should be, particularly on the total catch that's taken out of the population. So this is why our team here in New England, their number one priority right now is putting in place a much more robust system to monitor how many fish are actually caught on the water. And that's going to do two things. One, it's going to make these models perform better. You may have heard when anyone talks about any kind of model, garbage in gives you garbage out. Right? So we're going to put better data in and hopefully get better answers coming out. But beyond what these models are telling us, this kind of information will let us track in a much more high resolution and real-time way how the system is evolving in response to climate change. Which species are we catching where? Are they spawning? Are they feeding? What are they feeding on? All that information we're missing now. And if we start to get information off the boats at the time they're actually catching the fish, we may actually be able to keep pace with this system and adapt in a faster way. Now, those are all actions that rely on federal regulators, right? That's kind of out of our hands. We can lobby those groups, but we're relying on other decision makers. There's actually a whole set of actions that we can actually take at the local level, at the municipal level, that will further help this system build resilience. So many of these fish, even though they tend to be caught further offshore, often in their earlier, at the early ages, they will come right into shore and use eelgrass beds, use salt marshes, use shellfish reefs as kind of juvenile nursery habitats. Well, those habitats are particularly vulnerable to climate change. They're in areas where the impacts of storms are severe, sea level rise, warming, so they're strained. But they're also strained by a whole set of impacts that we actually have a lot of control over, right down to the municipal level. So rethinking coastal development, rethinking pollution management, rethinking boating, where boat speed zones are set and where anchoring takes place. There's a whole set of impacts that we have a lot of power to lift off of these habitats that may give them and the fish stocks that depend on them a fighting chance against climate change. So, you know, when I look ahead to what this fishery is going to look like in the future, it's going to be very different from the past. But I don't think it's going away. I think if we can find the resolve to take these steps, then we can keep this fishery around. All right, so I need to hand this over to Kristin in a moment. I'm just going to say a word or two about the work I'm doing in China right now, and then just invite further conversation later. China's at an interesting point in their fishery management history. They're basically where we were 40 years ago, where after mismanagement or complete absence of management, which led to collapse of many fish stocks, they're actually taking this seriously and trying to get it right. So we're working with provincial governments, which is where a lot of the management in practice actually happens, to just build the fundamental building blocks, monitoring systems, enforcement systems, the kind of science that's needed to set catch limits and the implementation of those catch limits. But the thing I find pretty cool is that at the same time, we're working with some of the higher level technical institutions in China to ask these questions about climate adaptation and climate resilience. And what that means is that as they build a more robust and more functional fishery management system, they may be able to instill these resilience principles from the outset. The ones that we're actually trying to kind of instill into a system after the fact, they have a chance to do it all together at the same time. It's going to be a heavy lift, but I'm actually really encouraged by what I see going on there. And I think what's really important, and this will be my closing comment, is the reason I think our work in China is so important is because, you know, China's a big country. It has a large exclusive economic zone. It has a lot of habitat and biological diversity. So in its own right, it's an important environmental target. But it's also, of course, an incredibly influential nation. And if China can actually build some successes and build some pride in better climate-ready fisheries management, they could become a really powerful force for exporting those ideas internationally. And that's our real ambition there. But that starts with turning things around on the domestic level and then getting that to roll out overseas. So with that, I'll wrap up and hand it over to Kristin, who's going to talk about some more of the interesting international work we're doing.
So I just want to give a little preface to what you're going to say, because I want to highlight something that was a theme running through what Jake was talking about, which is that climate change is kind of helping us grow up. You know, and I was in the Clinton administration. I was appointed to oversee a number of things. Fish was one of them. And dealing with fishing in New England was the biggest pain in the neck, because it was really like sort of managing a bunch of unruly 13-year-olds. And what Jake told you about the fact that the New England Fishery Management Council set a protected area to welcome fish as climate changes is jaw-dropping to me. We once tried to do a small little thing along like 1% of what Jake was just talking about, and the Congress got so mad at us that I happened to be the policy chief for the Secretary of Commerce. They defunded the Secretary's office, specifying my position. The government could spend no money on David Festa's position. And that was for something that would even, it pales in comparison. So the fact that people are coming together, kind of growing up a little bit,
saying, all right, there are some limits, we really need to figure out what to do, and approaching things in a way that really wouldn't have been possible before. And Kristin's going to tell you, I wanted to give that because I thought that was a really helpful segue into what you're going to talk about on another coast.
Yes, thank you very much. I'm Kristin Kleisner, and I'm also a fisheries scientist. Oh, sorry, can you hear that? Okay. With EDF, and I've not had as long a tenure as David and Jake, but I have been consistent with the Oceans program, so that's something. And I'm really excited to talk to you about a project that EDF has been working on for the past several years in the Humboldt Current region, which is down in South America, along the west coast of South America. And that region is very special because it's actually one of the most productive, or it is the most productive region in the world in terms of its fisheries. And the reason for that is that, well, basically the Humboldt Current itself, which runs from the Antarctic up the west coast of South America, it drives upwelling. And upwelling is basically when you have cold, nutrient-rich waters from the deep that come to the surface, and they bring with it those nutrients that are so important for the base of the food web. So little things like phytoplankton love these nutrients, and those phytoplankton are very important also for species like anchoveta or anchovy and sardine. So it's incredibly important. Those are big fisheries in Chile and Peru where we work, and now those systems, I would say that they're variable. So the variance is caused by this phenomena called the ENSO cycle, or the El Nino Southern Oscillation. And you might have heard, oh, we're going into El Nino year, or it's going to be a La Nina, La Nina is coming, it's going to be dry. Or what happens in the Humboldt Current when you have an El Nino year or years is that it's a warm water and you have a suppression of the upwelling. So it's actually worse conditions for anchovy, better for sardine. And during La Nina, the opposite happens. So what we call it's a boom and bust cycle, and these species flip-flop. So what that means for the fisheries managers in that area is that they're used to variability. These guys have seen it. They're like, okay, this system is crazy. It goes back and forth. It's got a lot of interannual variability. But now we have a new actor on the stage, and that's climate change. So long-term climate change is basically when you hear, oh, the ocean waters are warming over the past decades. And when that happens, and that new actor is actually influencing that interannual variability that's already present in the system, and it's causing things to go haywire. And it's creating more uncertainty and problems for the fisheries managers there. So this region, those fisheries are so important, and so important for not just the people in that region in terms of their livelihoods and food security, but important globally. Anchovy and sardine are important in fish meal and fish oils, so these have global repercussions. What we're seeing with climate change, or what's forecasted to happen, is that the upwelling intensity in the region, it's not uniform down the whole west coast of South America. It's actually, there's a big hotspot off Peru. So that's why Peru has the largest catch in the world of Peruvian anchoveta, or has for many years. And this upwelling intensity, this hotspot, is expected to shift toward the pole. So if that happens, that's going to mean a lot of changes in the species composition in the region. And when you think about that region, and you think about Chile and Peru, which up until not that long ago, they actually had a huge dispute, were nearly at war over their maritime boundary or border. This is going to create the potential for a lot of conflict if we don't have management in place that's cohesive and collaborative. And so that's really the driver for a lot of the work that we do in the Oceans program in that region. And so we, in that spirit, EDF has been working with our partners in the region from the science and management institutions in both Chile and Peru to develop and co-create a plan for climate-ready fishery management over the next 10, 20, 30 years. And so we've had meetings over the past couple of years. We've hosted our partners here in the US. We have held meetings down in the region as well. And we've co-created this plan, which is really interesting and really important and groundbreaking in a way, because we are working together across two countries to talk about what climate resilience means and climate-ready fishery management. And so this plan entails several things, or three main things I'll talk quickly about. The first is that we need to basically understand those changes that are going to happen. And so as Jake talked about, there are models that are out there, models that we look at the physical changes in the system, things like temperature change and salinity changes and what's going to happen, you know, as we're going forward. And so what we're doing right now is actually working with our partners with a global high-resolution climate model. And when I say high resolution, it's high spatial resolution. So that means if you think of like a high-def television and compare that with the old standard definition televisions, the picture is really nice and sharp and crisp and clear. So we get a better picture of what's going on. We are looking at those physical changes, and we're hoping to use that model, or the goal is to use that model to then understand, okay, given these physical changes, what's going to happen to the fisheries in that region? And then how can we look at our management and come up with adaptive management solutions that will deal with these changes? So that's one thing. And that model was actually developed by our partners here at NOAA in the US. And so it's a nice bridging of the science and sharing of data and knowledge across countries. The second thing is that, first of all, we have to have the data to go into the model. So you need clear, consistent, and synoptic monitoring of all these ocean conditions, of the biology, what's happening on the water. And Chile, they monitor their waters, Peru monitors their waters, but those two systems don't necessarily talk to each other. And this is the Humboldt Current ecosystem. So what we're looking to do is develop and put in place a coastal ocean observing system. It's called a COOS. And across the whole Humboldt Current system that is synoptic and that can basically monitor these changes so that we can manage them. Then the third thing is that once we have this information, we need to be able to tell managers, okay, what do you do with this? If you see these changes on the water, what does that mean? What do I do in terms of the management for this fishery? So we're working on early warning indicators, so things that tell us, okay, if we see this temperature change or this particular change in the ocean, that means that this is likely to happen and you should do this. So that's an actionable project that we're working on right now, which is really great. And so all these pieces together are really important because they're building climate resilience in this very important system. And they're also bolstering that collaboration, which is going to be critical as you see species shifting and productivity changes around the world. And what's happening in the Humboldt Current is a model for we're seeing it around the globe. We're seeing it here in our waters in New England. So we think that, the lessons that we're learning there, we know that there are going to be lessons that we can take to other places. So we're really excited about this work. And yeah, thank you.
So I'm going to open it up for questions as soon as I turn my mic back on. I'm going to open it up for questions. You'll be first. But I want to say one quick thing about something that Kristin said. Remember that bit where she said Peru and Chile were militarizing, getting ready to go to war? Okay, that's how intense the long-standing conflicts have been between those two countries. But what EDF was able to do, Kristin and her team were able to do, is create a safe space for those two countries to come together, because they knew they had to do something different. Again, back to the very same thing that happened on this coast. Same thing that happened in coastal Louisiana. They knew they had to do something different. Kristin and her team were able to offer an on-ramp for a conversation that allowed them to look at stuff. And in fact, one of the first places that they came together to talk was in our office in Washington, D.C. That we, in this sense, we're sort of Switzerland, in the context of how our managers from two countries that are friends and enemies, the old frenemy, really find a place to sit down and talk where they can look at data, where they can ask for different models, where they can begin to have a conversation because they know that things are going to be different and there needs to be some way of dealing with it. One is winner take all, we'll go to war and the winner gets it all, or we're going to sort it out for a lot less loss of life, a lot less money, and a lot better outcome for the planet and for people. And that's the genius of what Kristin and Jake and many other folks at EDF are doing, taking this moment when the impacts of climate change are becoming very real and very motivating, and not wasting a second of that good crisis to help people change how they think and change the relationship that we have to natural resources and the natural world. So that's why I think there is a moment of optimism that the impacts of climate change can drive us to a much better place than we are today. We wish we could have gotten there before, but we're here to take advantage of what we have now. And that doesn't mean that we need to take our foot off the gas on reducing emissions. There's no amount of resilience that can manage a world that is 4 or 5 or 6 degrees warmer than what it is today. That's not an option. But we really can create a future that will be different from today, but actually a really livable planet. So I will stop, and I promised you first question. So remember, let us know who you are.
My name is Gail Pat, and I'm an emeritus professor of biology at Boston University, and I've been studying ovulation and fertilization and embryonic development for 70 years. Okay, can you hear me now? I'm an retired embryologist. I've been studying reproduction of vertebrate animals since the 1950s at Boston University. And what I wonder is why you folks aren't investigating conditions of fertilization. I mean, we don't know that fishes or amphibians or reptiles or any mammals are producing fewer eggs than they used to. And there are ways of increasing the rate of fertilization of those eggs, which would lead to much higher production of fertilized eggs and developing embryos, which would lead to a much higher population of organisms in the oceans. And I don't think that I see any particular change in the studies of reproductive physiology amongst the vertebrates that I ought to be seeing if there's a problem.
Colleagues? That's an invitation to nerd out a bit, so I'm gonna no, it's a great question. I think in the fish world, which I know best, that work is happening. I fully agree we need more of it. So these models we use to estimate the status of these populations, they're kind of they tend to be structured just by the total biomass, the total weight of fish out there. Well, right, and I think we're moving in that direction, slowly, but we're getting there. So there has been work that, well, I mean, some of it. So there was an interesting paper that came out last year that was talking about the recent success and the future of the Maine lobster fishery. So Maine lobster is a big success story in the region. It's the most valuable fishery in the country and has been for several years. One of the reasons this paper argues that it has been so is because they have had a long-standing prohibition on keeping egg-bearing females. So unlike fish, lobsters do us a favor and carry all their eggs on the underside of their tails. So you flip them over, you see they're full of eggs. Many fisheries have a rule that if you see that, you put them back in the water. Maine does another step and says you have to cut a little notch in their tail, such that if anyone else catches that same female, they'll see, oops, she's an egg producer. Even if she's not right now, she goes back in the water. The argument has been that's helped the fishery sustain itself, but they actually do some forward forecasting and say this is going to be even more important as fertilization rates and egg and larval survival rates start to go downhill. And that's something that's going to be unavoidable, but the way we can sort of counterbalance that is getting more eggs in the system. So that protecting these large egg-bearing females has built this into a successful fishery and can help keep it going as the ecosystem becomes less favorable to lobsters.
is planned to be to increase the egg production of females, because that's a doable thing. It's hormonal.
Well, I always remember one of my great mentors, Jane Lubchenco, who was the head of the NOAA, National Oceanic and Atmospheric Administration, which we all know is NOAA. It's not a guy. It's an agency. But she became the head of that and was a mentor of mine for many years. And she taught me that fat females rock. So the bigger the fish, the more eggs they produce. And so if we can do what Jake was describing and protect the females, even as they get very, very large, that by natural selection is going to produce more eggs. It's not quite the directed research you're talking about, but it's helping nature out. So I'm going to move on to a couple of other questions. Thank you.
Speaking back to what she said about embryological stuff,
And you are?
I am Denise King, and
Hi,
I'm
Denise.
just a girl from Dorchester.
Me too.
Albeit, I joined the Lifelong Learning Center, and our thing this morning in Braintree was about climate change in the library. Speaking to what she said about embryological thing, wasn't there something in the news recently about aquatic hypoxia and a bunch of lobsters that were just found dead on the ocean floor off the coast here? And how could you have embryological development if you have dead zones and aquatic hypoxia right in your region, a dead zone? And not for nothing, I just caught the tail end of a PBS thing that was talking about an Italy-sized dead zone that sounded like it was in the Mediterranean or some such place. And that's a climate change, resilience, adaptation thing.
So, do you mind? Can I? So dead zones are generally the product of runoff, polluted runoff coming largely from agricultural operations. Really, since the 1950s, the agricultural community has been driven by one metric and one metric, well, 1.5 metrics. Yield is the first metric and profitability is the second metric. And I want to emphasize that profitability is a really important metric and we should never lose it because farmers have to make a living. They can't make a living, they can't farm, that means you don't have food. So this isn't about sort of corporate profitability, it's really about at the individual farmer level. The problem with that model is when you pursue yield over everything else, you wind up with dead zones. You wind up with pollinator crashes. You wind up with toxic drinking water. You wind up with soils that are depleted and ultimately you see yields crash. So I was just talking to my colleagues, this is my 5th city in 7 days. And one of the things I've been doing is this is the time of year when the global community gets together and talks about food. I don't know why they have to do it this time of year, but they do it this time of year. So I've been to several of these global meetings. I have been blown away by the unanimity, and this is a big change from even 5 years ago, the unanimity of how we have to get away from a model that is yield first, profit second, and nothing third. And we really need to break that model, recreate that model around food that is nutritious, climate resilient, and rebuilding the natural capacity of the land to maintain crops and to hold water, a whole suite of things. And I'm not at a conference where it's a bunch of environmentalists. To be honest, every single one of them I've been to, Environmental Defense Fund has been the only environmental NGO present. This is what the insiders are talking about. So to your point, this is a symptom of a unilateral way that we used to think about what we're trying to do. I'm trying to optimize for fish catch, corn yield, whatever. And this is my job. This is what I do. And you see it in government, you see it in businesses, and that model is beginning to be broken by the impacts that we're feeling around climate change. And while we really wish it was broken for reasons that it should have been broken before, which is it's wrong, we are now beginning to see countries and companies and individual NGOs come together around what are some of these new models that are going to be able to help us reduce these big dead zones
and get away from a model that's all about yield and to a model that's much more about sustainability. I don't know if you guys want to add anything to that. You're in the field, so.
I mean, I can add from the standpoint of understanding the physical environment, like I was talking about off the coast of the Humboldt Current. For example, there's an oxygen minimum zone. It's not a dead zone, but it also does constrain where we find fish, and that's also something that's predicted to change with climate change. And so I would just add that, yes, I agree with everything David said. And then from the science side of things, I think if you're going to look at studies that involve anything to do with reproductive success of species, or where those species are going to shift to, or have habitat, then we need to be able to understand where those hypoxic zones are, or oxygen minimum zones, and a whole host of other habitat constraining variables. So,
Can I make 2 quick comments on that?
And gentleman in the check shirt, and then you in the back. You'll be the next 2.
Okay, I'll try to be quick. 2 comments. One is I think that's a good example of the point I made at the end of my remarks about what we can do at the local level to start to alleviate other impacts to give the system a fighting chance against climate change. That's an example of not doing that. But the reality is that, just to go back to lobster, I think is a good example, and you were talking about lobsters, there are going to be changes in these systems, and it will make some of these areas places where certain species can't live, or at least aren't as abundant as they once were. And we're starting to see the signs of that in Maine. And Maine has put itself in a tricky spot, because the golden egg that has been the lobster fishery for so long has kind of pushed aside all motivation to rebuild other species that have been depleted. That's going to make them far less resilient, because lobster aren't going to go away, but they're not going to be catching as much, they're not going to be making as much, and they don't have a diversified portfolio of species to fish like they used to. If you look at the pie chart of fishery catch in Maine even 30 years ago, it was a bunch of wedges of comparable size of all sorts of different species. Now it's 95% lobster and a sliver everything else. The guys up there are starting to try to catch up on this. I was talking to a friend of mine who's a lobsterman recently. I hadn't talked to him for a while. I said, Bob, what are you doing? He said, actually just got myself a kelp farming lease. I said, really? He's like, yeah, lobster isn't going to be what it was 5 years from now, and I need something else to fall back on. And so you're seeing more of these guys look to aquaculture and starting to get more serious about recovering other species. So, bringing back ecological and biological diversity is a really important climate resilience and economic resilience strategy.
Okay, sir.
Hi, I'm Nick Rahman. I also live in Dorchester, which was also a resilience-related issue for 40 years ago with the busing crisis, et cetera, and we've done very well. I want to bring out a couple of angles that seem to me not to be present in the way you're talking about this with the public. I take it that this is one of those ways, this kind of meeting. I wonder if this kind of information is being choked off by an inattention to a certain kind of problem with how people are seeing the response now to the environmental frontier we're at, which is a very low-level kind of depression, I think, on the part of most people. They're just going to try to turn away or hope somebody's going to deal with it, but it's not going to be them unless they're putting out the trash at the curb. 2 questions. Have you had instituted within Environmental Defense Fund an ongoing means of accessing the politicians in Washington on a regular basis to communicate issues of optimism and forward thinking in a way that would change some of the negativism that we hear all the time? Secondly, how do people such as knowledgeable and resourceful people here in Boston, we have the highest concentration of universities in the world, how do we engage that on a more sustainable and concentrated and attentive basis to attend to these issues in ways that other people who have suggestions can integrate them into a forward-moving dynamic? My third point is in relation to a frustration of my own, I have, to me, a question of feasibility about, as I mentioned to Mr. Festa earlier, a system that would transfer heat, an engineered system that would transfer heat from Greenland, from the snowpack in Greenland, to continental U.S. to fulfill the heating needs of cities and for rural populations. Why couldn't that be engineered into our electric and photovoltaic systems and whatever else is needed? I don't know how to get the suggestion put forward into a conversation between engineers and policymakers and experienced persons such as yourselves to say, can we study this, in an instant time kind of fashion, build the models, and convince the governments in the New England zone, for example, and Greenland that this can be done. I think it would be a very simple, straightforward, common sense solution to part of the problem. So those three questions come together for me tonight.
So I'm going to work backwards. Engineering question should be asked to engineers, and Gwen Ruda is actually an engineer, and I think she is, she has ducked out momentarily, but she is also one of the senior people here in Boston, so I will defer to her on that question. Academic connections, this is something that EDF takes very seriously. We have an Office of the Chief Scientist who's deeply influential, and one of the things that, and his name's Steve Hamburg, one of the things that Steve is, and he lives up in New Hampshire, so next door. One of the things that he has really done well is built long-term and deep partnerships with academic institutions. We can always do better, we're always looking for more, but I feel that we are one of the best connected with some of the leading institutions. My field in agriculture, Cornell is one of the great land grant colleges, and we're working with them. University of California, Davis, we have a huge program with them. University of California, Santa Barbara, the Oceans program has, I think, one of the most productive NGO academic partnerships. So I'm really proud of the work that we're doing there. And then on the politics, that's another night. But yes, we're deeply active, and I'll give you one little story of the kinds of things we try to do. I told you the story of coastal Louisiana. The Republican state official that we worked with is a gentleman named Garrett Graves, deeply Republican, deeply conservative. He gets himself, after working with us on the coastal plan, he gets elected to Congress. And when the Democrats took over 2 years ago, they created a select committee on climate change. And Garrett Graves said, I'd like to be the ranking Republican member on that committee. So we really do work very hard at long-run cultivation of political leaders and then being able to deploy them or help them be deployed in places where they can really influence the outcome. Elizabeth Gore is the head of our political unit, and a guy named Tom Bonfiglio is the head of our C4, or lobbying group. We actually spend money on elections and try to influence outcomes. We've got a pretty good batting average. But those two people are really influential, and I'm sure there's going to be another one of these sometime in the future where you're going to be able to geek out on politics. So we had in the back.
Yes. I'm Karen Dowsett, just a girl from Cape Cod. But I'm curious to know, given the state of our fisheries, and you spoke very completely about the condition of the cod, and knowing that 85 to 90% of the natural oyster reefs are gone worldwide, and their role in providing habitat and literally a nursery system for the water column. So I'm curious to know what EDF has done to take a look at this in promoting reef restoration.
That's a great question, and I think I wish my friend and mentor Doug Rader, who is our chief ocean scientist, were here, because Doug has spent many years, including his time before EDF and with EDF. He works out of our Raleigh office. He spent a lot of time working on habitat and ecological restoration in the Albemarle Pamlico system, which covered all the major habitats there, and he could speak to that from a position of much more experience than I can. I think, here I might actually pivot a little bit to my work in China, where, the sort of history of seafood production in China was not unlike many places where fishery catch rose very rapidly before management of fisheries could catch up, and before you knew what happened, they'd collapsed. Now, most countries at that stage go through a painful process like we did, like Chile did, like many places did, of reforming their system and building things back up. China made the decision to kind of push fisheries aside and go whole hog on aquaculture, making the same mistake. They overdeveloped aquaculture to the point it was having all sorts of impacts on coastal ecosystems. They almost had to cancel the sailing race at the Beijing Olympics because of impacts that were linked to aquaculture, mismanaged aquaculture. Now, though, there's a really interesting conversation going on there. They're scaling back aquaculture production, but as they think now about actually starting to rebuild ecosystems, including wild fisheries, and try to deal with mitigating climate change, is there a role for particularly shellfish and seaweed aquaculture to provide, to filter water, provide habitat, as you said, capture carbon, and start to bring back some of those ecosystem services that have been lost by natural systems. So I also live up in New Hampshire in the seacoast area, and we're starting to actually have some of these debates in my hometown. I live in Durham, where the University of New Hampshire is. For the first time in 30 years, the state has certified the mouth of the Oyster River for shellfish production. And there were several growers ready to pounce with lease applications. Now, I was quite supportive of this. There was a big backlash about, kind of effects on the viewscape. And I get that. Great Bay is beautiful. However, I was like, look, basically exactly what you said. We have lost so much of the ecological services that these natural shellfish provided. There's a lot, the Nature Conservancy is doing great work up there to try to rebuild natural oyster beds and oyster reefs. But aquaculture may actually have a big role to play here in filling in some of those services. So I think that's one of the big things I would point to is we can actually kind of kill multiple birds. I probably shouldn't use that metaphor. We can actually accomplish many things with one action. We can produce seafood,
Right.
We can capture carbon, we can create habitat, all in a way that really enhances both the ecology and the economy.
Right. Well, and especially because oysters love nitrogen. It's pretty simple.
Hi, my name's Janine, and I live here in Boston. Thank you for your information today. About 2 weeks ago, I got to see a documentary film called Artificial. I don't know if you've heard of it. It's actually underwritten by Patagonia, so I'm a little. But it had to do with the farm fishing of salmon off the coast of Washington, and the fact that the farmed fish were released then into the wild to sort of mate and propagate with the wild salmon, which is highly sought after. But in fact, they're bringing the whole fish stock down in terms of, you have just genetically, it's bringing it all down. So the question was, we've been really promoting farm fishing as a way to replenish and sort of feed the nation. But if it's really bringing down all of this, the actual genetic integrity of the fish itself, what is your feeling on that, and what do you think are some next steps?
So I'm glad you asked that question, because I think many of us need to be more careful when we talk about aquaculture. Aquaculture is many different things. It's sort of like, baseball teams are not all the same, right? The Red Sox are a lovable, likable, admirable team. The Yankees are not, right? They're both baseball teams, but they have very different characteristics and value to the world. Aquaculture is kind of the same way. There are modes of aquaculture that, as we were discussing, that are actually, I believe, especially in altered and stressed ecosystems, a huge net positive. There are others that can have these very real impacts. I think the salmon industry, to their credit, has made really great strides over the years in containment, so in not allowing these escapements that release non-native or at least genetically inferior fish into the system, in reducing the amount of animal-based feeds, moving more to plant-based feeds. So, it's an evolving industry, but I think it's important when we talk about aquaculture to make those distinctions. So when I sort of prop up aquaculture for helping to recover ecosystems, I'm talking largely about shellfish, kelp, seaweed. Finfish are a very different story. And there's plenty of examples of good, sustainable, well-managed finfish aquaculture, and others that are not so much. So there's Red Sox and Yankees in the aquaculture.
All right, other questions? Yes, ma'am.
My name's Laura McMurray. I live in Cambridge. My question is, I'd like a little bit, perhaps from Kristin, details about how you get Chile and Peru to get together in your office. Details like how does this organization function in that way? So it sounds very interesting, but I'm just curious, and it would help me know whether I'd be how interested I am in supporting the organization.
Yeah, that's a great question. Well, I'd first say that EDF, the foundation of EDF is its science. So that's really where we started, was bringing together the scientists. Scientists love to get together and talk and talk and talk and talk and share ideas and collaborate. So the issue really wasn't there. It was bringing the managers together, which we succeeded by, I would say, first of all, getting those scientists together to flesh out what is that path forward, what does it look like, and how do we communicate it to the managers? Because once they understand the issue, okay, well, we need to understand these stocks shifting, from, one country X into country Y's waters. What do we do? How do we put in place management interventions that are adaptive and responsive on a time scale that works with the changes that we're seeing on the water? And so we brought the scientists together first. We talked about these issues. We co-created that 10, 20, 30-year plan that I was talking about together. With advice, there were managers in the room too, but then we took it to a larger meeting where we had more input from those managers and more of I'd say a science foundation to work from, to illustrate the problem and to explain where we go. And I think we have examples in New England that Jake could probably point to too, of doing a similar, taking a similar approach, working from the science and proving our point that way, illustrating what is going to happen.
I mean, just in general, I would say the principles are, first of all, we go into a situation as best we sometimes forget this rule, but what we try to do every single time is say, what problem do you want to solve? As opposed to, you have a problem that we'd like to help you solve. Are you okay with that?
Yeah.
It's really, what problem do you want to solve? And then the second thing is that we remember these are relationships. Any success is like a poker game played over many, many, many hands. And so we show up over and over and over again. And then the third thing is to bring our expertise to bear after we've really built an understanding of what problem it is they want to solve, what the intersection is between our skill set and what they want to solve, and that we built that trust that we're not taking sides, we're not trying to get an outcome that we think is right, but we're really that independent, we're like the Switzerland,
Yeah.
that we're really able, and we become the trusted third party that can help these folks get together. And so when we say, well, why don't you come over to our place? It's neutral ground, no one's favored. Come on over to our place. Why don't we just sit down and have a chat about this? I think that's our secret sauce and how we really work, whether it's in fish or agriculture or microgrids or any of the things we're doing. This is some of the health work we do. This is I think one of the real secret sauces of EDF.
Yeah, I would add too that building on that trust idea, that was really, really important for the work that we were doing. So when we went in, for example, with the climate model, there's a inherent distrust down there. Oh, you're coming in to take our data, or to, we weren't telling them what their problem was. They came to us and they said, okay, can we work together to co-create a solution? But then when we said, okay, yes, and when we brought our expertise into the room, we weren't saying, you give us the information and we'll run away and we'll go run the model and then we'll tell you what the answer is. We said, would you like to work on the model together? Or, can we give you this model output and you use it? They said, oh, okay, yeah, we'll do that, and that's great. And so we've built this collaboration, and so there are things that they've asked us, could you take a lead on this? Yes, we'd be happy to. We'd be happy to do that with your support and your help. So I think that's a really important point.
Yes, sir. And do we have a second one after that? We can get kind of microphones positioned.
Hello. My name is Peter Papesh. I am impressed by the EDF use of Roger Fisher's getting to yes mechanisms, which is wonderful. I also was a co-author of a harebrained idea to create a 14-mile-long dam that could protect all the low-lying areas of the Metro Boston estuary. It cost a little bit too much for the appetites of the local politicians, and it couldn't be financed privately. My question is, have you been invited, and if you were, would you be interested in helping create a charrette of the sort that you did in Louisiana for the Boston area? Because Boston is, as you know, one of the prime targets of sea level rise, and the effects of sea level rise will be the fragmentation of the physical area, which means all the municipalities are going to go bust. They are going to disappear. And with it, the greater Boston metropolitan economic engine, which extends from Boston all the way up to New Hampshire, to westward to Worcester, and down into Providence, Rhode Island. The floor is yours.
The general answer is yes, but the more specific answer is that, again, remember what I had just said, that the first thing we say is, well, what problem do you want to solve? So we would need to hear from the right stakeholders here that, yes, we would like to solve the problem of sea level rise. If we don't hear that, we're not the kind of group that's going to say, well, by God, Boston's really super important, which it is. We're going to go in there and make people do things that they don't think they want to do. That's just not where we're strong. There are other groups that do that, and they're really, really important groups in the ecosystem of creating progress. But that's not how we work on these resource issues. So we have recently been invited into New York and New Jersey because they've been going down. We've taken them down to coastal Louisiana and seen what we've done there. And they're like, okay, we'd like you to come up here and start talking with us. So yes, same thing in coastal North Carolina. And we're starting some conversations with folks in Florida. Those are still too premature to say that we're going to do anything there. But there really does need to be this, before we get involved, this gestation period and this back and forth. We really try to understand what problem they're trying to solve, how they frame it, whether we have the right skills and the right temperament to be the group that comes in. And when the answer is yes, we're willing to make a decade-long commitment to it. But because it is a major commitment, we want to make sure that we're being invited in by the people who actually will need to make the change. So I don't know the answer to your question. Well, I think we go in the back.
My name is Frank Mead. I live in Boston, but I spend a lot of time from the Midwest, and I've spent a lot of time in the Michigan area. We've been focusing on the oceans tonight, but I'm curious if you're doing any work in the Great Lakes, which has got to be one of the largest freshwater resources in the world, if not the largest. And we've had the highest level of water this year, and we're being threatened by the Asian carp and other types of shellfish. And are you doing any work there?
Yeah, we actually have major efforts in the Midwest. Our efforts are focused on agriculture there, and our goal is to eliminate polluted runoff off of agricultural lands. That has the benefit of helping with some of the water quality problems you're talking about, but extra fertilizer on land is also turns into a gas called nitrous oxide that is 300 times more powerful than CO2 as a global warming gas. So if we can eliminate fertilizer waste, we eliminate a major chunk of the U.S. emission inventory. That's what U.S. inventory on greenhouse gases, and we clean up our water. And by the way, we make farming more profitable. I'm happy to talk to you more about the work that we do there, but it's a major part of the work that EDF does in this space.
Hi, I'm Daniel Heider. I work for a very successful biotech company up on the North Shore. I have a couple questions about anadromous fish, and we're talking about inland fish and ocean fish, and at the intersection we have salmon and herring. I'm lucky enough to do some commercial fishing in Alaska. We had another record harvest up in Bristol Bay this year. I'm curious if there's much data on the effects of salmon farms on the wild populations. I only know it by hearsay and what I see. And then much closer to home, my company, we're in the Ipswich River watershed, and I'd love to see restoration of the herring run. The Mystic River here in Boston has a herring run of several 100,000 fish. The Ipswich River has a herring run of maybe 100 fish, 200 fish. And I wonder if that's just because of the dam that's at the head of the tide, or is there something else we could be doing as residents of the North Shore to restore the Ipswich River to health?
All right, so my colleagues are looking at me because I spent a lot of years working on anadromous fish, including herring, and it is still one of my great sort of scientific and conservation loves. The short answer is, with any sea-run fish population, the dam is almost certainly the majority of your problem. There's very few changes we impose upon natural systems that are so binary. So I was talking about, eelgrass and salt marsh, and those kind of erode, but there's still some there. Dams basically take tens or hundreds of miles of rivers and make them completely inaccessible to species that depend upon them. Fish ladders help to a point, but actually there's been some really interesting and important work, I think, coming out in recent years to suggest that fish ladders, for the most part, are designed for a certain set of flow conditions. Those conditions are not holding up under climate change, because one of, I think, the underappreciated effects of climate change, and it's happening in New England more strongly than just about anywhere else in the U.S., is increasingly variable rainfall patterns. So overall precipitation is increasing. I mean, I can't believe how wet the last 2 falls have been. I remember raking dry leaves when I was a kid. So it's going up, but it's also getting more variable. We're having more flood years and more drought years. And what that means is these fish ladders that are engineered for a certain set of flow conditions could be overrun, or they could be completely dry. So wherever possible, get dams out of the water. That'll get you a long way. There's plenty of other impacts that these fish face. We spent a few years working on, there was sea-run herring, I have found, are one of those species that actually really bring people together at local levels. I mean, you're probably experiencing this in Ipswich, that people get fired up about these fish, because it's really cool to walk down to a river and just see swarms of these fish heading upriver, and eagles and ospreys diving after them. I mean, it's wild. And so people tend to get together and work on watershed management and work on fish passage project. As David said, that was my first gig at EDF. But what people were finding was that despite some of those efforts, the runs weren't coming back like they'd hoped. And it got people looking offshore. Because even though we call these river herring, they actually spend the majority of their lives at sea. And as the midwater trawl fleet for sea herring emerged in New England, they were actually incidentally scooping up a lot of these river herring. So we worked for many years to do the science on that and to get the policies in place that started to curb that problem. So it's a really complex conservation problem where you have these impacts that are highly localized. There's a little dam, you can put your hand on it. You're also dealing with large offshore fleets, and you're dealing with global climate change, all coming together in your backyard. But the starting point should be your dam.
Who's next? Here in front. And who's after that?
My name is Suzanne Lavoie. I don't have a question as much as I wanted to just let everybody know, and you know, that the city of Boston has an aggressive program for the coastline. I live on the waterfront in Boston, and it is looking at each of the waterfront communities, identifying what the climate change impacts are going to be and producing recommendations. They're currently working on downtown Boston, the North End, and the Wharf District area, and they will be producing something by the end of the year. Are you familiar with that?
I can take this one, and so can Jake. I currently serve on the Boston Conservation Commission, and Jake did before me, before he moved to New Hampshire.
She took my seat when I
took
moved.
his seat. But yes, we're definitely very familiar with the Climate Ready Boston plan, and
Oh, that's great.
yes, it's a very important part of the whole climate resilience package that looks at the infrastructure and all of the buildings and parks and land that's within any certain distance from any water body in the city. And there's a lot of water here, so.
Right. So do you find that this is compatible with what you all are trying to do then?
Definitely, yeah, and yeah, for sure. It is. It's part. Do you want to add to that, Jake? Or
All I'd say is I've made these comments several times about the things we can do at the local level. I don't know if I would have made those comments before my service on the commission.
Yeah.
So much of the work I'd done is at federal, maybe some state level policy. You know, I was living in the city, and you know, this was my home. My daughter was born here, and all my work was further afield. It's like, I want to do something here. So I joined the Conservation Commission and started to see the real impacts you could have at a very local and at the municipal level. And, and it sounds like Kristin's been having the same experience.
yes, yeah, it's
Because
very.
we're working with the city, and we're actually in our downtown waterfront community looking at eventually creating a 5-foot barrier around Boston Harbor.
Yes. Yeah, so a lot of the projects that the commission sees in terms of infrastructure and building projects have to have some sort of climate resilient measures in place. And the things that we're seeing are barriers, floodgates. We will look for green infrastructure, green roofs. There's lots of different types of solutions. And then we also, of course, are looking at the new flood maps. So that's they're actually looking at changing some of our ordinances within the commission and how we are effective at setting conditions for different special habitat areas. So Jake would know we don't have any conditions, for example, for land subject to coastal storm flow. But now we're looking at putting those in place because it's so important for everywhere around Boston to have this protection in place. They're looking at increasing the distance from riverfront area that would come under our jurisdiction, and they're incorporating now new flood maps from FEMA, which illustrate the potential change in sea level rise. So yeah, these are all things that we need to take into account. And then as commissioners, we try to make sure that the projects that come before us have some climate resiliency in the plans, baked in. And thank you.
We have one in the back.
Yeah. Hi, my name is Toby Wall. I live in Cambridge, and I'm really impressed by the notion of agriculture, improvements that you're making. Love the idea of modeling away from yield into something else. So I want to ask you the question, is anyone asking you How do we move away from animal-based protein and into more of a plant-based protein? Is anyone asking to engage you in that conversation? And if so, where is it being manifested?
Yeah, we get asked all the time. From an environmental perspective, it is perhaps more complicated than you might think to start with. One of the assumptions is that if we stop eating meat, then all of the grain that the cows and pigs and chickens eat will either go to human consumption or we won't need to grow that anymore. The data doesn't really show that. If you look at data in the United States for how much corn, wheat, and soy has been planted since the records began in 1932, roughly speaking, the same amount of land is in crop production as was in 1932. So what I take away from that is that these lands are really good at growing these basic grains, and they're going to grow those basic grains, and they'll be used for different things. But where our focus has been is, all right, if this land, this almost 400 million acres that are in row crop production, that's going to be in row crop production regardless of what eats it. And therefore, EDF's focus has been less on sort of questions about plant-based protein or animal-based protein, and more on how do we manage this amazingly huge block of land that's going to be used to grow grains of some kind. That's a practical and not a moral or sort of ethical decision on our part. The issue of animal agriculture is really complex because it involves culture. It involves your sense of animal welfare and your sense of ethics. It's a very complex field. One of the things that we've been thinking about is on the food safety side of things. So Environmental Defense Fund does have a very strong presence in human health, and we have been very active in food safety on the toxics question. We haven't really moved past that. But one of the things that we're beginning to contemplate right now is as we move into an era where there is more alt meat, as we tend to call it, some of this is really just taking anything that you could buy in the grocery store and mushing it together in a way that tastes good. That's not that much of an issue, but the alt meat, and this is why we use alt meat, not plant-based meat, alt meat includes that, but it also includes a lot of very novel processing and the use of engineered organisms to create proteins, to create flavor profiles. So you have the potential for very novel foods, and there's not a lot of good regulatory science behind how to think about these foods. So one of the things we're contemplating is, do we want to get involved in this? Because the last thing we would want is like a really good alternative to emerge, but there was something in it that we hadn't really expected, something we hadn't tested for, and a bunch of kids in Minnesota die. And then no one eats it, and we're back to square one. So that's one thing. The other thing is that animals actually have a very important role in agriculture. Our prairies evolved with grazers, with animals eating grass. So the notion of healthy ecosystems absent any kind of livestock on them is a little hard to get your head around if you're an ecologist. So animals have a very interesting and constructive role to play in ag. Do we need all the animals we have right now? Do we have projections of income going up and how many more cows and pigs there will be? This clearly is concerning. So it's an area that we're beginning to look at, but we're also respectful of some of the complexities and some of the cultural issues that have to go in. And we're really trying to figure out where is that intervention, where EDF special sauce can make a difference and really help us transition to a system that is going to be better for the planet and better for us. We got time for one more, and you're our lucky contestant.
I'm Mike Mallory. I really like that answer to the last question. I'd like to add to that issue. It makes a lot of difference on what kind of meat you eat. It takes 10 pounds of grain to make 1 pound of beef, but only 2 pounds of grain to make 1 pound of fish. And 5 pounds for 1 pound of pork, 3 pounds for 1 pound of chicken. So it matters what you eat. But also, they found that asparagus seaweed at 1% fed to cows reduces their burping by 66%, which cuts way down on their greenhouse emissions. That is methane. And so this will be an important addition to their diet in the near future. And that seaweed will be grown in the ocean. So I wanted to make that comment.
Well, the other thing that I mentioned our partnership with the University of California at Santa Barbara. One of the things that they are looking at is the ability of open ocean seaweed aquaculture to help reduce the dead zones, because the dead zones are dead because they have a whole lot of nutrients in them, and if you can put these fast-growing seaweeds in there, you know, their modeling is suggesting that you could really help shrink that dead zone. So there's these very interesting feedback loops that can exist. And for those of you who may be wondering why we're so obsessed with cow burps, cows burp methane, and methane is a very, very powerful greenhouse gas. So if you could address the methane problem, you really shrink the greenhouse gas footprint of cows. And I would just say this is another one of the things that makes me wary of wading into some of the debates around animal agriculture, because you oftentimes see somebody really advocating for something for a reason that's not the one they're talking about. So I have been in debates with people or conversations with people where what they're really trying to do, they're in animal welfare. They're concerned about animal welfare. So they latch onto the climate issue and say, well, you can't eat it because of the climate. But then that opens up and say, well, if I solve the climate issue, can I still eat it? You know, it's like, well, no. Well, okay, well, you haven't really been genuine with me about why you're doing this. And we try to be, this is part of we just try to be genuine all the time. This is why we're interested in this. This is the problem we're trying to solve. There may be other problems that you're also trying to solve, but this is where we are. And again, really trying to create those long-term partnerships, those poker games played over many hands, where we develop these deep alliances. And as people realize that the status quo is going to need to change, that we can be part of that dialogue and help guide that and guide those good intentions that people have that often get blown apart in times of crisis. We can help magnify those good intentions and create results that are durable, good for the planet and good for people. And speaking of good for people, you guys are really good for coming out, sitting through all of this until 8 o'clock at night. We can't thank you enough for your support and inspiration that you provide to us. So I will say good night and thank you.